Oh, okay. All right. We're live. All right. Our next talk is approaching parity. Oh, you can see it here. Considerations for adapting enterprise monitoring and incident response capabilities for efficacy in the cloud environments and how to operationalize those capabilities with a playbook. Matt, our next speaker, is an information security practitioner with over 20 years of IT experience. He helps protect Cisco's network and assets as a first responder on the computer security incident response team. He participates in groups such as the Defense Security Information Exchange and North Carolina InfraGard, and Matt's hobbies include making his own sauerkraut and competitive rifle shooting. Welcome, Matt.
Thank you. Pleased to be here. Good morning. Thank you for joining us. Thanks for the B-Sides crew for everything that they've done to put this together. So here's my contact information. My role at Cisco CSIRT involves protecting corporate assets by serving as an incident responder. One of my focuses is on monitoring and response in cloud environments. And that's what we're going to talk about today. So this talk is about how CSIRT adapts our security monitoring and IR posture for monitoring and infrastructure as a service cloud environments. And the story is based on lessons learned to date from monitoring some Amazon Web Services tenants. So it also includes top of mind from evaluating different environments, not just AWS. And I should point out that although a lot of the terms that I use are AWS specific, we see architectural similarities with other vendors, and so the concepts that I talk about should apply just as well to other environments. And finally, this talk is intended for security practitioners, incident responders, and basically anyone whose role involves puts them in a place where they're responsible for monitoring and responding in cloud environments. So, what do we want? Well, starting off, no matter which environment your organization consumes, I think it's safe to say that we pretty much want the same thing, right? We don't want to lose visibility in cloud environments. We want a tool set that allows us to detect compromise, and of course, we want to maintain and hopefully improve our efficacy as responders. So where do we start with that? And as an aside, first I would just say, remember that an infrastructure as a service, typically the logs must be enabled. They're not on by default, and that's because they typically incur storage charges. So we can start by examining native vendor monitoring capabilities. For one, doing so will help illustrate the different vendor names for similar technologies. And you can maintain your own surveys, like the ones that I've put together here. But vendors are now publishing their own guides, and quite frankly, it's easier just to use the ones that they've put together. An example is the Google Cloud Platform for AWS Professionals Guide. And then second, knowing these native capabilities will help you plan your security monitoring architecture and your kit. So where native capability gaps exist, you can then look toward workarounds to bridge the gap or third-party solutions. And some third-party solutions design their kit to integrate with multiple IaaS vendors, right? So and the native capability will dictate differences in how the third-party solution implements. For example, the StealthWatch Cloud is something that natively it consumes native flows in Amazon Web Services, but due to the architectural differences, if you were to deploy in other environments, you would be required to use a sensor for those collections. So, new features and releases and upgraded tooling tend to be the norm for many providers. It's sort of the odd week that I look in my email and don't see notification of yet another feature release or improvement from AWS. And also keep in mind that there's an almost endless continuum of kit you can evaluate. But you need to make sure that you don't let that distract you from your mission, which is to obtain the security logs that you need and make them actionable. And then I have one example that's I'll share with you. So StealthWatch Cloud, which is a Cisco acquisition, consumes CloudTrail and AWS virtual private cloud flow logs. And it works, the product works to try and solve the context question around the network and infrastructure events in the cloud. The idea is that by baselining what is normal, so it can alert you to what is abnormal. And just from my own experience, in the week before we were to go live, Amazon Web Services released their equivalent solution, GuardDuty, that had a similar enough feature set that it gave us pause on our deployment so we could take a look and reevaluate the feature sets. Another consideration. So for environments where you're responsible for monitoring multiple tenants, I think attribution information is important. Tenant owners are typically the ones who will be able to provide context around events, right? And knowing context is important because obviously we don't want to bother tenants with alerts that are not meaningful for them. So when we see interesting events taking place from our kit, we need to know things like, is that a brute force attack or is it just a broken script? Or is that a compromised machine instance that we've detected? What is it? What does it do? Is it a test host that we can isolate and or just shut down? Or is it the web interface for something more important like a revenue generating service? These are important questions. We want to bring the appropriate response to the condition that we detect. So tenant context can help paint the picture in these situations. And the example that I'm showing here is a Splunk dashboard where we try to enrich context data from AWS so that it also includes employee-specific attributes. Logging events is sort of a talk unto itself. Where's Blaine? Is he here? There he is. But here are some things to think about. First, where possible, relegate alerting to a single mechanism. Your analysts will thank you. We use Splunk. Next, consider that some logs will be more interesting from a security monitoring perspective than others. And to that end, third-party solutions and software development kits can increase the volume of the read or describe type of events that are logged. And these obviously might be less interesting to a responder than write or update events. And so to limit log ingestion volume, particularly where that's a concern for cost, where appropriate, I suggest consider indexing only the more interesting parts into your seam. Leave the less interesting logs in their native repository, and then because they may later come in handy for investigations, and you can seek them out only if needed. And then also be prepared for the scarcity of logs too. Serverless service offerings tend to abstract the virtual machine, for example, so you can run DNS using Route 53. But just as that machine is abstracted, keep in mind that so too may be the logs that would be useful to go along with it. And then one other thing to prepare for is the infrastructure as a service SOC may alert. Think AWS EC2 abuse notifications for those who are familiar with these. But the SOC will sometimes lack the attribution and context that you know about anything that's organization specific that can give that important context around those events and let you decide whether it's just an event or an actual incident. But I will say that until you've deployed your monitoring solution, these alerts can be used as another layer of telemetry. In either case, be prepared because the SOC will contact you, and you, at a minimum, need to have some response capability. And then one last consideration is the bill. It's a great quick check. If you know what your typical monthly charges are, this can be a great indicator. So, for example, if your bill goes from $500 a month to $50,000, that's a pretty good sign that something's changed. And, you just have to figure out what and why. So now let's switch gears, and I'll talk a little bit about how the AWS environment that CSIRT monitors. So this is a simplified picture and version of the story. Continuous Security Buddy is an internal tool set that we use to monitor our tenants. We came about a year ago to have multiple company-owned tenants. This adoption happened fairly rapidly over the course of a few months. And at that time, CSIRT was working on our initial AWS monitoring solution, based mainly on CloudTrail logs and billing logs, and a little bit more that I'll get to in a moment. And we were fortunate in that our kit was adopted by our InfoSec group at large and became a core component of the Continuous Security Buddy monitoring. So the kit initially had a button click aspect, which everyone here knows that if you need to ask your users to click a button, you're already behind the game. So the initial version was suboptimal. We don't want our telemetry or kit deployment to rely on the tenant taking action. There is a carrot component for those who may have multiple tenants to roll up under a corporate account and to the tune of discounted pricing. That's something you need to talk to your infrastructure as a provider representative, of course, about. But the kit could be installed via the command line or via browser. Simply put, the solution uses template stacks in order to deploy roles. The roles that are installed include an investigator role that can be activated on a temporary basis. And it looks for, the kit also looks for and reports on permissive S3 policies, provides VM and other best practice notifications. Once this kit's installed, we're able to capture CloudTrail logs. We're able to capture VPC flow and OS query, which you could think of those as it's an open source that will give you inventory information on the local machine. CloudTrail is the AWS name for the infrastructure logs. Stealthwatch Cloud will ingest the VPC flow and provide alerting. And then, as I mentioned, the OS query captures host level inventory. But capturing just these three things it's just a start. There are so many other log sources that we may want to use, and every practitioner knows that the more telemetry that the more layers of telemetry that you have available, the better equipped you are to detect and respond to security incidents. Again, recall when making decisions about what sorts of logs you'll go after, that the vendor native capability surveys will really help guide your efforts on which tool is best to use in your environment. So we're ingesting lots of logs, right? Just like this dog trying to drink from the sprinkler. But how do we make sense of so much log data? And it's a good question, right? So now that I have this mountain of data, what do I do with it? And so what I'd like to touch on now is a short overview of the CSIRT playbook. And then just stepping back from that for a moment, if you think in terms of a recipe for an incident response shop, these are sort of the ingredients that we think are required to bring a true incident response capability to bear, right? You have to have management support. You have to have the technology in place. You have to have people who know what to do with the technology. And then you have to have process written around that. Otherwise, everything has to be done manually. And so we use a playbook. That is the process by which we automate our monitoring response. And we also use continuous feedback on the plays to help ensure efficacy. So the question is, well, first of all, playbook is a talk all into itself. And the question often comes up, what does our playbook look like? So I will show an example here. But if you would like a deep discussion, some of the members of our CSIRT family have written about our playbook approach. So a lot of people are surprised to learn that we don't use a traditional SIEM monitoring solution for the work that we do. And some of them are also surprised that to learn that even though we are a Splunk shop, we don't rely on Splunk Enterprise Security. Rather, our approach is that we write each of our own plays internally. And so what you see here are this is the development process in brief behind each play. And it's each play that we write, we're looking through Splunk, and we're trying in order to garner the results. But each one of those queries is written based on the questions that you see here. What am I trying to protect, right? What are the threats against it? How can I detect them? And then how do we respond when we see these things happen? So here's an example play, an actual Splunk query from one of our plays. We have over 200 plays deployed to monitor and protect our networks. This example play is based on AWS CloudTrail logs, and it alerts us to the application of overly permissive S3 bucket policy, which everyone knows if that's unchecked or unintentional can result in data loss. And I'm probably going really fast here, so I apologize. I want to touch on IR containment and a little bit about mitigation next. So, what's the model for IR in the cloud? The providers commonly describe a shared model for security, and it goes something like this. The provider does the things like securing the data center, right? They secure the electricity, the facility, the infrastructure, the heating and cooling, etc. And then you take responsibility as you get nearer to the virtual machine instance, the storage bucket, or the service layer, right? But really what all this means is that you, the tenant owner, is ultimately on the hook for security. And as an aside, the CSIRT is that I work for is a small shop, and in our case, we are neither intended nor are we resourced to perform the tenant support function. So likewise, when an incident is detected, the first action is typically to contact the tenant owner for additional context, containment, and then ultimately remediation activity. So a little bit more on the shared responsibility. Essentially, it's the CERT working incidents with the tenant whenever possible to ensure that the tenant mitigates and contains detected security incidents as appropriate. So this includes things like using tenant context in order to get the correct response. If you think back to my example about a Pont machine, right? Before we isolate it, we would really like to know as much as possible about it. Is it development? Is it production? Is it a machine that generates revenue for the company? It's important that we bring the correct response to bear. So, how do you really know in environments where you're responsible for monitoring multiple tenants, what function that host provides in absence of that context, right? Now, of course, we can reach into that environment as needed and assume the role that allows our investigators to come in and evaluate or examine things, but that's the last resort, right? That's not ideal. It's sort of like when you fix a family member's laptop, right, who doesn't know anything about computers. Once you've done that, you now own everything that goes wrong with that thing from then on. Also, as a CERT, we don't generate our revenue by selling security products. Rather, we demonstrate our value to the organization by helping mitigate risk. And this value can be expressed in terms like in numbers, right? So you can talk about things like time to detect and time to contain. Generally speaking, one way to gauge the efficacy of your CERT is by using these numbers. And so this is an example timeline of an incident response. You have the stages where the analyst determines a compromise has occurred. The analyst notifies the tenant, and the tenant takes a mitigating action, right? So that brings you from detection to containment, and that sort of encompasses the timeline. Now, of course, there may be examples where the numbers will turn out differently. Of course, shops can often bring forensic capabilities to bear if the case warrants it. But that doesn't happen for every incident that we detect. In some cases, it's simply remediate, get the tenant back to a known good configuration, and then drive on. But think about this timeline for the next examples that I'll share with you. So this is that IR shared model when it works as expected. So in this case, we detected, validated, contacted the tenant and advised, and then the tenant remediated and notified us of such. The impact was not disruptive, and we closed the case. All this took place in under a day. And again, you, the tenant, are responsible for your cloud security. Most public cloud environments, oh no, I think we've already covered this. Yeah, I don't want to chase that any further. So, one thing to think about is without attribution, without knowing the tenant contact to get in touch with to look into this, what sort of problems can you encounter? It could be, problems mitigating, problems, it could have a negative business impact. It runs the whole gamut. That was one that shows when it works as intended, but also I will share a case where it demonstrates a gap. And this is a case where, due to a mixture of attribution problems, potentially unresponsive tenant, and a daily continued influx of new abuse notifications, really lasted a lot longer than is ideal. So, but it raises a good question, because we come across this, and the question is, what happens when the tenant contact is unresponsive? You will occasionally run across, I call them derelict tenants. The lights are on, but no one answers the door. So in that case, your SOC investigator may have to invoke a privileged role and take action. Right. My suggestion there is that in that case, when you have to do that, it's invasive. Make sure that you document your actions. in case your actions have to withstand scrutiny after the fact. And then one other point to this end, where possible, work to include this mitigation and containment functionality in a central spot. Your analysts, again, will thank you. They don't necessarily all want to become familiar with the inner workings of how to get into a tenant through the CLI and contain an EC2 with an ingress policy. So if you can wrap that around or wrap that into a web page, then that will help put you ahead of the game. And then finally, the worst case scenario, if the keys to the kingdom, and by that I mean if the tenant root credentials are gone, you may have no other recourse to remediate than invoking vendor support. Okay, so with that, I'd like to touch on just a few retrospectives and a little and close on some root cause. So we've moved everything to the cloud, right? And everything is different now than it was in our data center, right? Who would raise their hand and say that? Well, it turns out that the more things change, the more they stay the same. And so I just wanted to share with you, here are 3 conditions that we frequently see in cloud that have been the root cause for security incidents that we've worked. And obviously the idea here is that by preventing these mistakes, you can reduce the risk to your cloud environment. We want to do things like harden our cloud environments by reducing the attack surface wherever possible and prevent the conditions that lead to compromise. These are all the sorts of opportunities that we can take before the fact to improve the overall security posture of our cloud presence. So first up, think overly permissive network ingress. Think of overly permissive network ingress policies as potentially careless firewall policies, right, that can let anyone on the internet access your cloud host. I mean, obviously there will be situations where a permissive ingress policy is desired, for example, when you're running a publicly accessible web server. But ingress policies otherwise should be scoped according to the principle of least privilege, allowing network access only from those hosts who require it. And then you could draw the same analogy for storage buckets like S3 or Elastic Block Storage. It's the same idea here. So, right, unless there's a specific need, like a public document repository, for example, avoid setting bucket permissions to be world readable. The risk here, obviously, is unintentional exposure of sensitive data. And then, number 2, as with permissive ingress policies, leaked credentials are another pitfall to a secure cloud environment and can lead to data loss. The common vector here is credential leakage, and access key is committed to GitHub or other publicly accessible repositories such that they can be acquired, and unauthorized users can simply go to GitHub and use those credentials to access your environment. Same thing that you've probably heard 1,000 times. Again, avoid this by not hard-coding credentials into source. If there's no way around it, sanitize those credentials from code before commit. And then another step is to make sure that you're restricting access to your code repository to only the people that need it. And then finally, insecure machine instances. These are the images that are either vulnerable from a configuration standpoint or a software perspective. And then when they're spun up, they're run either with weak credentials or sometimes with no credentials at all. The lack of strong credentials, particularly when combined with an overly permissive network ingress policy, can make these hosts an easy target for hackers. These machines exposed to the internet in this weak security configuration, once they get popped, they can quickly be subverted and used to distribute do all kinds of naughty stuff, distribute illicit files, distribute malware, and participate in distributed denial of service campaigns, and can generally have a negative impact on your organization's reputation. So that is my talk. And one last thing. I was advised by a colleague who previewed this talk that the presentation lacks pictures of clouds. So here you go. Thank you.